Welcome to this presentation on partial autocorrelation function. We will show that ACF cannot be used for AR processes. Partial autocorrelation function proposed. We will present an example with a Scilab code. Can we use ACF to find the order of an AR process? For this, we will start with a very simple AR process. The simplest one here, it has only one unknown, so it is an AR1 process. We will multiply by y of k minus 1, k minus 2 up to k minus n and take expectation. When you multiply by k minus 1, you get this equation. The difference between these two is 1, so you get this. Difference between these two is 0, you get this 0. And because of causality, it becomes 0 on the right hand side. Similarly, you can proceed with k minus 2 and so on, all the way up to k minus n. We get this. Let us consider the last equation. So this is gamma yy of n equals minus of this, and when substituted from the previous equation becomes like this, and finally we arrive at this expression, minus 1 to the power n a1n into gamma yy of 0. This is the equation we arrived at in the previous slide. Therefore, when I scale this by gamma yy of 0, divide both sides by this gamma yy of 0, I get this expression. As a result, ACF never dies for an AR process. It is a slowly decaying function. Hence, ACF cannot be used for detecting the order of an AR process. We will show that partial autocorrelation function can be used for AR processes. In fact, we will only describe the process here. The procedure is explained next. What is the procedure? We are given an ARP process. You take j equals 1 and then assume that the system is an ARJ model. That means you stop here. That means you will, using this method, you will calculate only A1 1 from this equation. So then multiply by y of n minus k and take expectation, and let this k be repeated for values of 1, 2, 3 and so on up to j. Arrive at j equations. That is, you multiply this by y of n minus 1, get an equation, n minus 2, take an equation, y of n minus 3, arrive at this equation, so on and so forth, arrive at j equations. Do this j times and solve these j equations for ajj, namely the last one that you get here. That is the only thing that we are going to use. You do not have to worry about the previous constants. You get ajj. Now repeat this for several j values. You do this for j equals 1. If this j is less than j max, do this for 2, 3 and so on, all the way up to j max. What is j max? J max should be chosen such that it is greater than the expected p. Plot of ajj versus j will have a cutoff from j equals p plus 1 onwards. So this is the algorithm. I would like you to work this out, do this for j equals 1, j equals 2 and so on with this example. Take this example, apply the procedure shown in the previous slide, and you will get these values. A11 is minus 0.67, A22 is 0.5, A33 is 0. I would want you to do this yourself, although the answer is given in the book. And A33 is 0. In fact, for all values greater than 2, that is from 3 onwards, these coefficients will be 0, and the details of the calculation are in the book. I would urge you to work this out yourself first, and if you have difficulty, go and check the book. It is also solved for a general AR2 process in the book. Here is the Scilab code for this, PACF_x.sce, and another code PACF.sci. Now you get minus 0.67 and plus 0.5 as shown earlier, and of course this code is a general code, it calculates for several orders, and you see that it becomes 0 from 3 onwards. To summarize, first MA process which we saw in the previous video, we plotted ACF, and a plot of this ACF versus K becomes 0 for all K greater than this Q. This was known as the ACF plot. For an AR process, we start with a process of this type with P unknowns A1 through AP, and the procedure is given here. First assume P is equal to 1, calculate A1, call it A11, do this for P equals 2, do this enough number of times and plot A11 through AJJ versus J. From J equals P plus 1 onwards, AJJ will become 0, and that is how you identify the order of this ARP process. We will use these techniques, AR and MA order determination methods, in the next video. If you recall, in one of the earlier videos we showed that the residue was not white, you have to model it with more elaborate models. Now we have developed the required machinery, namely ACF and PACF. We will use them in the next video so that we will arrive at more detailed noise models. With this, we have come to the end of this presentation. Thanks for joining. Goodbye.